Welcome to today's physics class, and today we'll be talking about scalar and vector quantities. And what is scalar quantities? Scalar quantities are quantities that has magnitude or numerical value only. An example of scalar quantity are length, mass, volume, density, temperature, time, speed, and energy. And what is vector quantity? Vector quantities are those which has both magnitude or numerical value and direction. Such quantities are not completely described unless their magnitude and direction are specified. Examples of vector quantities are displacement, velocity, acceleration, weight, force, and momentum. And how do we represent velocity? The vector representation vectors are represented by a straight line with an arrowhead. Here is a straight line that has an arrowhead. The length of the straight line is drawn proportional to the magnitude or numerical value of the vector. The magnitude or numerical value of the vector. The arrowhead indicates its direction. From here, we'll talk about addition of vector. We have addition of vectors. Under the addition of vector, we talk about when two vectors are moving in opposite or the same direction, and also when two vectors are inclined at an angle to each other. So one, we talk about when two vectors and Q are moving in the same or opposite direction. If the two vectors Q and P are moving in this direction, their resultant vector will be equal to P plus Q. And if the two vectors are moving in opposite direction, the resultant vector will be equal to P minus Q. And what is resultant vectors? Resultant vectors is the vectors that result from the addition of two or more vectors, or the combined effect of all the individual vectors, and it is represented in magnitude and direction. If we are to represent the resultant vector, which is resultant vector, a straight line has an arrowhead. The length of the line represents the sum of all the individual vectors. Sum of all individual vectors. And the arrowhead indicates its direction. Let's talk about when two vectors are inclined at an angle theta to each other. So, when two vectors P and Q are inclined at an angle theta to each other. Under this motion, we have two methods of finding the horizontal vector. We have one, the graphical method, and two, the component method. And two, component method. And under the graphical method, we have the parallelogram law or method. Law or method, and also the triangle method. While the component method is also called resolution of vector. Under the graphical method, let's talk about the parallelogram law or method. What is parallelogram law? Parallelogram law states that if two vectors are represented in magnitude and direction by the adjacent side of a parallelogram, the diagonal of the parallelogram drawn from the point of intersection represents the horizontal vector in magnitude and direction. If these are the two vectors that are equal at an angle, assume here the angle between the two vectors to be 45 degrees. The line drawn from this point of intersection represents the horizontal vector. When you look at these two lines, this and this line are parallel. So you can extend parallel line. I will say that for an angle to be formed between two parallel lines, there must be a third line, which is called the transversal line, cutting across through the parallel line. And this parallel line is acting as a transversal. So if you look at this angle is equal to this angle. Here will now be 45 degrees. And from here, we can find this angle theta. We can find this angle theta using angle at a straight line. We say that angle at a straight line is equal to 180. Now theta is equal to 180 minus 45. Our angle will now be 135 degrees. So this angle will now be equal to 135 degrees. From here, we can find our horizontal vector using cosine rule. Say that the resultant square is equal to the two vector, which is p square plus q square minus 2 times p times q cos theta. And these cosine rules are particularly useful for solving oblique triangle where angle is less than or greater than 90 degrees. While the direction of the horizontal vector alpha can be got to using the sine rule, which is equal to b over sine alpha equal to the resultant over sine theta. With this, we can find our direction of the direction of the resultant vector. And also, we can use Pythagoras theory to find the resultant vectors. That is when the angle theta is 90 degrees. Because cos 90 degree will give you 0. And when you impute the value into this cosine rule, what will remain will be r squared equal to p squared plus q squared, which is also equal to the Pythagoras theory. So whenever you are solving angle at 90 degrees, we use our Pythagoras theory to find the resultant vector. So let's talk about triangular method. Triangle method. The triangle method is also known as head to tail method. To add two vectors, place the tail of the second vector at the head of the first vector. The resulting vector is the sum of the two vectors. For example, if this is the first vector, has a line and arrowhead, the second vector, the tail of the second vector is placed at the head of the first vector, while the resultant vector is drawn from the tail of the first vector to the head of the second vector. So this will represent our resultant vector, and this is the triangle method. So from here, we'll talk about the component method or resolution of vector. Firstly, under this component method, talk about the resolution of one vector. Resolution of one vector. This here is our vertical component, and here is our horizontal component, S, and here is Y. So here is our vector. This is resolution of one vector. When you look at this vector is acting as a horizontal vector. Under this resolution of one vector, this involves the breaking down of this vector, this single vector, which is acting as a horizontal vector into its component part. This is the reverse process of finding two vectors which have the same effect as this vector or the horizontal vector. The component of the vector in a given direction is its effective value in that direction. So if we are to find the effective value of this vector v in the y component, we resolve this angle, this v, to the y component. So the effective value in the vertical component, which is y, will now be equal to v sine theta, while the effective value of this vector v to the horizontal component will now be s equal to v cos theta. Because whenever you are opening an angle, it is resolved as sine, and when you are closing an angle, it is resolved as cosine. So from here, we have our effective value of this vector v in the vertical component and also the horizontal component. So let's talk about the resolution of two or more vectors. Let's talk about the resolution of two or more vectors. Resolution of two or more vectors. See, here is our vertical component, and also here is our horizontal component. And this is force 1, here is force 2, and here is also force 3. Theta 1 and theta 2. Here is our force 4. If you look at this diagram, we have 4 force vectors. If you look at this, the purpose of this is to find the single resultant of all the vectors. That is the different resultant vectors and its direction. To find the resultant of these vectors, we resolve each vectors into 2 perpendicular directions, that is x and y, using our sign convention, where the vertical component, when you are going up, is positive, the downward is negative, while the right side of the horizontal is positive, and also the left side is negative. And we sum all the vertical components y and all the horizontal component s. With that, we can find the resultant vector using our Pythagorean theory. If you look at this, if we are to find the vertical component, which is y, this will now be equal to this force 1. When we resolve it to this one, opening the angle, and the sign convention is positive, this will now be positive f1. Since we are opening the angle, will now be sine theta 1 plus, when you resolve this f3 to the vertical, this will now be, since it is positive also, will now be f3 sine theta 2, and this is in the horizontal direction and this is in the vertical direction. And you look at this, this is negative f4, so minus f4. This is the sum of the vertical component. And if we are to sum all the horizontal components, we now have this f1, we resolve it to the horizontal. Since we are closing the angle, it will now be f1 cos theta 1, and it is positive. And when you look at this, we are resolving to the negative side. Since this side is negative, this will now be minus f3 cos theta 2, and our f2 is going the positive direction. This will now be plus f2. So we cannot resolve this to the horizontal. So this is the sum of the horizontal component. With this, we can find our resultant vector r square is equals to y square plus s square. This is method of finding our horizontal components, where the direction of the resultant component can be gotten from tan alpha equals to y over s. This we can find our horizontal vector and also the direction of the horizontal vector. So let's look at example 1. Example 1. A boy pulls his toy on a small horizontal surface with a rope inclined at 60 degrees to the horizontal. If the effective force pulling the toy along the horizontal surface is 5 Newton, calculate the tension in the rope. From here, from the given, if we assume the toy to be this, and a boy is pulling the toy at an angle theta to the horizontal, let's say here is the horizontal, at an angle 60. Since it is pulling the toy, this will be the direction of the horizontal vector at an angle 60 degrees to the horizontal. And the effective force pulling the toy along the horizontal surface is 5 Newton. We are asked to calculate the tension in the rope. From here, we can find our tension by resolving this to the horizontal component. This will now be 5 Newton equal to T cos 60 degree, since we are closing the angle. From here, we can get our T by making the T the subject of the formula, which is equal to 5 divided by cos 60. This will now be 10 Newton. This is our answer to this question. Let's look at example 2. Question 2. A boy is pulling a load of 150 Newton with a string inclined at an angle 30 degrees to the horizontal. If the tension in the string is 105 Newton, the force tending to lift the load off the ground is dash. Take sin 30 equal to half, cos 30 equal to root 3 over 2, and tan 30 equals to 1 over root 3. From the question, if this is the load and is acting downward, which is 150 Newton, a ball is pulling a load of this with a string inclined on this. Since it's pulling, this will be the direction of the vector, the horizontal, which is 30 degrees. And the tension in the string is equal to 105. You are asked to find the force tending to lift the load off the ground, which is this direction. You are asked to find the force tending to lift the load in the upward direction. And when you look at this diagram, it can also be written as this. Here's the force in the strings. This is our vertical component, and here is our load, which is 150 Newton. At an angle 30 degrees to the horizontal. From our resolution of one vector, we said that this is also acting as a horizontal vector, and this is the reversal process, which is breaking this vector into the vertical and the horizontal component. Because these horizontal vectors, its effective value is in the vertical component and horizontal component. So when you resolve this to the vertical, our force tending to lift the load upward will now be 105 sin 30. Here sin 30 is equals to 1 all over 2. Therefore, this will now be 1 all over 5 times 1 all over 2. 2 here we have 1. 2 into here we have 52.5 Newton. This is our answer to this question. Let's look at question 3. Question 3. The body is under the actions of two forces, 7 Newton and 10 Newton. Find the resultant of the two forces if A, the forces are parallel and act in the same direction. B, The forces are parallel and act in opposite direction. C. The two forces are equal at an angle to 60 degrees to each other. D. The two forces are equal at an angle of 160 degrees. Then E. The two forces act at 90 degrees to each other. So from here, you have to consider the two forces are parallel and act in the same direction. So we have the two forces that move in the same direction, which is 7 Newton and 10 Newton. Our horizontal vector will now be equal to 7 plus 10, which is equal to 17 Newton, since they are acting in the same direction. When we look at the B part, the forces are parallel and act in opposite direction. If here is the 7 Newton and is acting in the opposite direction to this 10 Newton, our horizontal vector will now be equal to 10 minus 7, which is equal to 3 Newton. So this is the B part of the question. Let's look at the C part. The C, two forces are equal at an angle of 60 degrees to each other, which is C. They are equal at an angle, here is first one, and here is the first two. They are equal at 60 degrees to each other. I will say that from the law of parallelogram, that the line drawn from this point of intersection, these two vectors represent the horizontal vector. So when you draw this, we have this. And we also said that these two lines are parallel, so this angle is equal to this angle. That is corresponding angle. From here, we can get this angle, which is 180 minus 60. So here will now be 120 degrees. From here, we can find our horizontal vector using the cosine rule. So here is 7 and here is 10 Newton. Here is also 7. This is equal to this, and here is also 10. This is equal to this. With this, we can find our horizontal vector using the cosine rule, which is r squared equal to 10 squared plus 7 squared minus 2 times 10 times 7 times cos 120. Cos 120 will be minus 0.5. That negative, we change this negative to be positive. So when you press your calculator, our horizontal vector r squared will now be equal to 219. Here arrow, which is our horizontal, now be root 219, which is equal to 14.8 Newton. Let's look at the D part of this question. So we say that the two forces are equal at an angle 160 to each other. Let's say here are the two forces that are equal at 160 degrees to each other. Here is 7 Newton and here is 10 Newton. I will say that from the law of parallelogram, that the diagonal drawn from the point of intersection represents the resultant vector. So here will be our horizontal vector. And this angle to this angle are equal. That is corresponding angle. When you subtract this from 180 and go in a straight line, here will now be 20 degrees. From here, we can find our resultant using the cosine rule. R squared is equals to 7 squared plus 10 squared minus 2 times 7 times 10 cos 20 degree. When you press your calculator, r squared will now be equal to 17.44. Therefore, our resultant vector will now be root 17.44. This will give 4.18 Newton. So let's look at the E part of the question. We say that the two forces act at 90 to each other. The two forces act at 90 to each other. If here are the two forces acting at 90 to each other, here is 7 Newton, here is 10 Newton. The horizontal vector will be the diagonal drawn from the point of intersection of the two vectors. This will represent our horizontal vector. And here equal to 90. So we can use our Pythagorean theory to find the horizontal vector. We say that r squared is equals to 7 squared plus 10 squared. Therefore, r squared will now be equal to 149. Our horizontal vector will now be root 149. When you press your calculator, you will have 12.2 Newton. This is our answer to this question. Let's look at question 4. Question 4. A lawnmower is pushed with a force of 50 Newton. If the angle between the handle of the mower and the ground is 30 degrees. 1. Calculate the magnitude of the force that is pressing the lawnmower directly into the ground. 2. Calculate the magnitude of the effective force that moves the mower forward. And 3. Why does the lawnmower move forward and not downward into the ground? Question 4. If this is the lawnmower, and the force to push the mower at an angle theta to the ground is equal to, since it's pushing it, this will be the direction of the vector, is equal to 50 Newton, the horizontal at an angle 30 degrees. We are asked to calculate the magnitude of the force that is pressing the lawnmower directly into the ground, which will be the weight. When you look at this question, you will see that we have a force vector that is equal at angle to the horizontal and also the weight. And there is no horizontal force here to find this effective value of the weight. We assume the lawnmower to be in equilibrium, where the vertical is the upward force will be equal to the downward force. So you will resolve this 50 Newton to the vertical direction to get our weight. This will now be sum of the vertical force equal to 0. When you resolve this to the vertical, and if you look at the direction, it's acting downward. So this will now be minus 50 sine 30, and this is also acting downward, minus weight equals to 0. So our weight will now be minus 50 times 1/2. This divide this will give you minus 25 Newton. This negative is indicating that it is going downward. So our weight will now be equal to 25 Newton. This is the answer to question 1. Let's look at the question 2. Say we should calculate the magnitude of the effective force that move the mower forward. If you look at this question, we are asked to calculate the force that is moving the mower in the horizontal direction. From this, we can find our horizontal component, which will now be F horizontal now be equal to 50 cos 30. And when you press your calculator, you know that this is equal to 43.3 Newton. This is our answer to this question. So it is moving in this direction, so it will now be positive 43.3 Newton. This is our answer to this question. And the question theory is showing that why does the lawnmower move forward and not downward into the ground? When you look at this, the value for the weight, the value of the force that is moving the object forward is greater than the weight. So this will make the mower to move forward. So this is our answer to this question. Please click on the subscription button to get more questions on scalar and vector quantity. Thank you.